Okay, I've been doing some thinking. Yeah, it can't be just straight element wire coming in and looping around because that's an electrical hazard. If you think about it, that would be a. I don't know if 240 volts goes across the elements or if it's 120 and neutral. Let me hold this right. 120 and neutral, 120 and neutral, 120 and neutral, or if it's 240. And 240. So regardless of that, bare element wire could be an electrical hazard. It should be, because that means your water is running across electrified conductors. But if they have a protective coating on them, then everything would be fine. But you would discover there's a problem when you get zapped. Another thing I was studying this a little closer. It looks like these elements. Turn on the big overhead light again. Looks like what they do is this cap here. One person's over here building this chassis minus the element. They're building this. Let's call it the case, so to speak. And there's these caps that are pre-punched out. They're literally punched to where the copper flares. If that one's overheated, you can almost see how this one is. The copper is flared outward. So some machine must come along on this cap, and through a jig, it literally punches out all 6 holes on one pressing action. And then these elements are bent up into a jig manually. It looks like manually bent. Could be, I don't see a reason to mass produce anything like this. And the physical element is what's sticking out, or the outside casing of the element, because we know we've got a blowout. The element's actually on the inside. But there's a copper tubing on the outside. That's what's poking out over here. So they slide the cap over the elements, and they have this thing boxed into like a jig. They know how much protrusion they need. And then they begin the task of soldering around the base of each one. Each one of these tubes are soldered on the inside. I've been doing some scraping around and examining, and each one is soldered as it exits. Hope the light catches some of that, but you can see where there's solder right around the element tube, and the tube protrudes out. And then they move on to soldering the outside as well. There's signs of soldering right here. So this part that's sticking out isn't like a flange they sit there and put on. This is the heating element sticking out. Of course, they've already pre-trimmed, and they know how long each one of these needs to be. They've pre-trimmed with an amount of the conductor protruding out. So they slip their cap on, they solder on the inside, and they come out here and they solder on the outside. And once that basically locks in all 6 termination points, which is the 3 elements, then I think what they do is they install, at this point there's no lug and there's no porcelain insulator yet. The next step I think they do is they insert this and they braze around the base. Once they get the brazing work done, then they slip these porcelain insulators over the wire and use epoxy. So they probably syringe some high temp epoxy around the tubing, on the inside of the tubing, slip these porcelain insulators on. That leaves the wire sticking out. And that's why you have a lot of runoff of this epoxy, high temp epoxy. Because when they push that white porcelain insulator in, some of it oozes out, which is no problem. They could wipe it off, but what's the point? And then the last step is they crimp the lugs on. As I've been staring at this a little bit more, since each one of these has a crack at the base, if I can clean out this trough, clean that out real well, I can torch and heat, probably the side profile here, just heat and heat and heat, and add flux and build up a shit ton of solder on each element. Let it run down and flow and build up solder around those cracks. I have to wonder why every one of them is cracked, and it makes me wonder if while they're doing the brazing work at the factory, there is a certain degree of compromisation going on at that connection point down in there. Seems like there's a lot of solder that's flowed away from the lowest point. Because this is bowl shaped. Why is the solder walking off and out away from where the element passes through? But I could resolder those down there to get rid of those cracks. And then from that point, I would need to have a substance that'll clean this real well, though, the inside of here, because it is really dirty. It needs really prepped really well before any solder work happens and flux work. Then for this piece here, I've been thinking about how does something like this happen? And it could be just a defective element. Meaning the way they make the elements, whether they pre-purchase element roll, which I would think that would be the smartest decision, or if they have a different company that makes the element all together. The way these are made, that porcelain could have had an air pocket. There could have been an air pocket, because I believe what happens is this porcelain, the element in the porcelain, the element's put in first, and the porcelain is a powder that is compacted and vibrated into the entire length of the tube, and it's put under high temperature to bake it, to make it solid. That's something I don't understand how they make elements. But I could fold this back over and put a patch on it and torch that, heat it up, and get that electrical element out of direct water. So I may not be done yet. And what I'm talking about is reasonable repairs. The only way I would move forward on repairing this is if I were able to clean up the base of every one of these, clean this entire bowl out with a liquid substance that can etch it. I would probably use like methyl ethyl ketone or maybe some etching compound, like in auto body work. Muriatic acid, I believe. Phosphoric acid should have taken away all this corrosion, but it did not. That I would clean this up first and then make sure it's fully dry and then retest and see if I have any resistance from any of the electrical probes to this case. If I end up in a situation where I have zero resistance, that tells me that I would now be able to proceed forward in heating up and pooling a lot of solder at the base of each one of these probes that passes through this cap. Once I do that, then I would probably have to come along and retouch up some of these insulators, because this one has slipped a little, like a 1/16 of an inch. It's slipped outward that way. See how it's flush with this lug? There's a gap. Whereas over here, there's a hardly no gap. This one slipped up a little bit, and it wasn't like that before I heated it. I'd have to warm these up and push these back in. But I bet that's just an epoxy to hold this bushing in there. And that's all it really is a bushing to keep that conductor steady as it's poking out. And then they can orient their lug on and use their hand tool to CAD weld to the heating element. So this dog may not hunt, but those are my last thoughts. I don't know when part 3 for this will come up, but I do want to try to tackle it because I like fixing things. That's how I'd go about if shit hit the fan. How do I really fix it? I need to clean up all of the interior and get to a point where I have no resistance from anywhere to the copper. And then next up, I would try to get tech support to try to divulge to me, why do I have 10 ohms or 10 or 11 ohms on element 1, but I got like 17 on 2 and 3? The problem I have with that is element 1 takes 3 loops. Okay? That's a longer element, therefore it should be a higher resistance on element 1. If it's longer, it should have a higher resistance. Element 2 and 3 are only 2 loops and much shorter. Those should be lower resistance values. There's so much I don't know, but that's the fun part of being curious and standing a chance of learning something, and also the pride in knowing you fixed something and you repaired it and got it back working again. No matter what it is facing you in life, you have something broke. Do you have the ability to fix it? All right, that's it for this. That's part 2. We'll talk to you later. See you. Bye.